All right, everybody, here I am, Mr. Myron, with another mini math Myron lesson, whatever you want to call it. I forget what I kept saying, but that's going to keep changing. As you'll see, I'm going to get weirder and weirder as the year goes on. I think funnier and funnier, but I think the students say weirder and weirder as the time goes on. And I get more and more comfortable teaching this lovely computer screen that's got a very bright light facing me as I make these videos. So here we are making another video trying to learn about how to find the prime factorization of a number. I joke, but this is a very important concept, important topic that we're going to be talking about. It's a big one for sixth grade. Actually, the prime factorization is going to help you with many concepts, many skills. Specifically, very soon, prime numbers, composite numbers, but also the greatest common factor, least common multiple. It's a nice way to find those very easily. So please make sure that you're understanding how to do this, how to find the prime factorization. There's multiple ways. I've seen many different names. We've got the prime factor tree. We've got the upside down division, monkey division, the birthday cake method. There's a bunch of them, and I'll show you what I like and why I like it in the future. But just try to stay with me. Again, if your notebook's not out, please go get your notebook, go get a pencil. Make sure you're doing this with me. Take notes on this one. This is a very important concept for the rest of the year. So again, finding the prime factorization of a number. Let's break this down. Prime, we're going to work on that on the next slide. Let's talk about this word, factorization. Right? We recently just finished finding common factors. Right? We recently just finished doing the factor rainbows, and what we're looking for was factors. Right? So we have that word in here, factor. So the factorization. A factorization is really just any multiplication problem, right? So 6 times 8 is a factorization. 6 times 8, we know, is 48. Okay? We could also say 2 times 3 times 8. These are all just a list, right? This is a factorization. This is a factorization. We could even break it down even more. 2 times 3 times 4 times 2, right? 2 times 3 is 6. 6 times 4 is 24. 24 times 2 is 48. All right, this is another factorization. Okay, and then we can even break that down even more. 2 times 3 times 2 times 2 times 2. This here is another factorization. If we were to do this out, 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. All of these are factorizations of the number 48. Okay, but we're looking for a specific one, the prime factorization. Okay, so we need to be able to figure out what the prime factorization is. In order to do that, we need to know what a prime number is. So let's talk about prime numbers and composite numbers. We have 2 different types of numbers. All right, one is prime and one is composite. And there's a very simple definition that splits them up. Okay, so the prime and composite has to do with the number of factors. Okay, that's what determines if a number is composite or if a number is prime. A number is composite if it has more than 2 factors. Okay, so we're going to write that. A composite number has more than 2 factors. So let's talk about an example of a composite number. 4. 4 is an example of a composite number. If we do the factors of 4, we have 1 times 4 and 2 times 2. So how many factors does 4 have? 3. Is 3 more than 2? Yes. So 4 is a composite number. All right, let's talk about the number 8. It's 1 times 8, 2 times 4. Again, how many factors? 1, 2, 3, 4. Is that more than 2? Yes. 8 is also a composite number. I'm sure you can think of a lot of composite numbers in your head right now. I know we have 2 even numbers. Let's talk about the number 15. All right, a lot of people will start to think prime and composite as odd and even, and we can't do that because there is one even number that is prime, and there are some odd numbers that are composite. Even numbers greater than 2 are all composite, just throwing it out there. So 15, we have 1 and 15, but we also have 3 and 5. Again, there's 4 factors. which is more than 2, making 15 a composite number. Composite numbers are any numbers with more than 2 factors. But again, the problem didn't say composite factorizations, it said prime factorizations. So when we're talking about prime factorizations, if we know the definition for composite is more than 2, the definition for prime numbers has exactly 2 factors. Okay, so it has to have 2 factors. Okay, each prime number has 1 as a factor and itself as a factor, and only those 2 numbers. So let's try to come up with a prime number. Okay, so I'm going to talk about a prime number. 5. Let's do a factor rainbow for 5. 1 times 5. So look at that so far. 1 and 5. 1 and itself. All right, does 2 fit into 5? 2, 4, 6. Nope. Does 3, 3, 6. Nope. Does 4, 4, 8. Nope. 5. Nope. The only 2 factors that the number 5 has are 1 and 5. So 5 is prime. 5 is prime. Okay, let's think about another number. 7. 1, 7. Does 2 fit into 7? Nope. Does 3 fit into 7? Nope. Does 4, 5, 6? Nope. The only factors it has is 1 and 7. Itself and 1. 7 is prime. What about the number 2? 1 times 2. And that's it. 2 is that weird one. 2 is an even number, but it is prime because it only has 2 factors, 1 and 2. All right, so composite numbers, more than 2 factors. Prime numbers, less than 2 factors. There's one number I do want to talk about. That's this number. Do you think it's prime or composite? I'll give you a few seconds to think about it. Is it prime or composite? Remember, composite is more than 1 factor. Composite is more than 2 factors, and prime is exactly 2 factors. Let's do a factor rainbow. 1 times 1. Do we write it again? How many factors does 1 have? It has 1. 1 is not a prime number, nor a composite number. Real quick side story. Most of my students will never, ever get this problem wrong because I did. When I was in grad school, I'm trying to be quick because I know you just want to get through this video. When I was in grad school, I was taking a math course. Again, these are math teachers trying to become math teachers. And I was taking a second grade, or it was not second grade, it was 2nd through 4th grade math class. Okay, so it was very easy for math teachers. I don't really know why we have to take it, but we have to take it. I wasn't complaining. It was an easy grade. At the time, I was heading into my final. That's the last test of the whole year, and I had 100. I got 100 on everything. Again, I'm not bragging. It's a 2nd through 4th grade class for someone who's trying to be a math teacher. They should be really good at 2nd and 4th grade math. Okay, so I had 100. Okay, class started at 6. It was a 3-hour class, so we had 6 to 9 o'clock at night to finish this test. Well, actually, the test didn't start till 6:15. But I had a goal. Yankees were on at 7 o'clock. I needed to be home. I needed to be home by 7 o'clock so I can watch the Yankee-Red Sox game. Pretty sure it was a playoff game, so it was a pretty big deal. So 7 o'clock, I need to be home. I need to leave by 6:45. That gives me 30 minutes to complete a test that we were given 3 hours for. Don't do that on my quizzes and tests. Don't rush through them, all right? Life lessons, because you make silly mistakes like I do. With one question, I'm cruising through this test. Easy, easy, easy. One question. Name 2 prime numbers. Name 2 prime numbers. Right? So I'm just going. Hopefully you feel like you're in class because the bell just rang, but you're not moving on. Stay with me. Name 2 prime numbers. That was the question. I go 1, 2. I was just being so easy, so smart, so quick. I just threw it on there, right? Finished my test. I hand it in. Okay, I hand it in. I'm driving home to my Yankee game. I think in my head, thinking about the test. Did I really put 1 is a prime number. 1 isn't a prime number. 1 is nothing. Right? All I have to do is this. Not 1, but 3. So I get home, I take out my phone, I send an email to my professor on number 17. I forget what the question was, but on number 17, it says name 2 prime numbers. I put 1 and 2. I know that 1's not a prime number. 1 is not a prime number because it only has one factor, 1 itself. There's no other factor. I said, it's not a prime number. Please give me credit. She goes, nope, I can't do that. 2 points off. Red pen, -2. 98 on the final exam. Mr. Meyer ended up with a 99. But let me tell you what, I am happy this happened to me because I will never forget that 1 is not a prime number. And a lot of my students will forget it because they all make fun of me saying that 1's not a prime number. But as long as you remember, listen, I can take it. You can make fun of me. 1 is not a prime number. It's nothing. It's a weirdo. It's on itself. It's on itself. I don't even know what the name is for it, but it's nothing. It's a weirdo. And it gave me 1 point off my grade. All right, back to the math. Let's do prime factorization now. So we're going to do our upside down division. That's what I call it. I've heard this called monkey division. I know some people do a factor tree. Some people do the birthday cake method. Listen, there's plenty of things out there. If you're going to get the right answer, you get the right answer. But this upside down division will not just help you with the prime factorization, but it'll help you a very quick way get the greatest common factor and least common multiple, which you'll see in a few videos. So here we go, upside down division, okay? Upside down division has to do with working down with these. I don't know why it's called upside down. Sorry. Are you getting the in-school feel with the video? I hope you are. Bells are ringing all over the place. Upside down division. I'm not really sure why it's called upside down division. Let's just take a look at it. So here we go. First off, we need to know what prime numbers are and what the main common prime numbers are. So these are the most important prime numbers to you at all times. These are all the prime numbers from 2 to 31. There are more prime numbers. I'm going to try to talk through it, but every time I think someone's going to call me, but they're just beeping. Like a little old beeper. Parents remember that, right? So 2 through 31, there are an infinite number of prime numbers. They never end. They actually don't even know what the greatest prime number. That was good. I was going through it, but then I stopped. All right, so we're 2 through 31. They go on forever, but these are the ones that you need to know most importantly. Okay, these are the ones you need to know most importantly. So let's talk about this. The very first thing you should do when you're starting to do the prime factorization, the upside down division, the monkey division, what do you want to call it, is list these out, write these down, know these, have these in the back of your head. Boom, there they are. Right, those are important for you. All right, we're going to use those to help us find the prime factorization. So we're going to do prime factorization of 36. Okay, here's why it's called upside down. I remember upside down division because our upside down division bar goes there. All right, so we're going to do 36. Okay, and what we're going to do is we're going to look for the prime factorization. All right, so what we need to do is we need to pull out a prime number that fits into 36. And what you're going to do is you're always going to start with the smallest prime number. What's the smallest prime number? 2. 2 is your smallest prime number. So we're going to put a 2 out here. What is 36 divided by 2? 18. Okay? Now 18 is still even, so can I pull out another 2? Right? 18 divided by 2 is 9. Can I pull out another 2? I can't. 9 is not even. So 9 divided by 2 doesn't work. So then I need to go to the next smallest prime number. What's the next smallest prime number? 3. What's 9 divided by 3? 9 divided by 3 is 3. Okay? After I do that, what's another prime number that fits into 3? 3 divided by 3, right? 3 divided by 3 is 1. Okay, it's the upside down birthday cake. It's a cake with a candle. You always end your prime factorization with the number 1. You always, always, always find your prime factorization, your end of your prime factorization with the number 1. Once you get to the number 1, you cannot break this down anymore. So what is the prime factorization? All of these numbers represent your prime factorization. So you need to write them. Again, a factorization is a multiplication like number sentence. So we need to write this in factorization form. 2 times 2 times 3 times 3. Now, math etiquette says to list all the smallest prime numbers first and getting bigger. Are you wrong if you don't do that? No, it just makes it nice and pretty. All right, so this is called expanded form. If you want to use exponents, you can do 2 to the second power times 3 to the second power. But let's focus on getting that. All right, so the biggest thing is you're doing upside down division, but you can only put on the left side prime numbers. If I pull the 4 out here, right? If I pull the 4 out here, it would give me a factorization, but not a prime factorization. I have to focus on pulling out prime numbers only. All right, let's do this. Prime factorization of 64, and hopefully there's no interruptions. At this point, I'm not thinking you're feeling extremely confident to try it on your own, but if you think you can, go for it. If you think you can, pause me, do it on your own, come back and see if you got it right. 64. Again, your thought should be, what's the smallest prime number? The smallest prime number is 2. Does 2 fit into 64? Yes. What is 64 divided by 2? 32. Okay, it's still even, so I know I can pull out another 2. What's 32 divided by 2? 16. Guess what? I'm still even. Pull out another 2. 16 divided by 2 is 8. Still even. What can I pull out? A 2. 8 divided by 2 is 4. 4 still even. I can pull out a 2. It's 4 divided by 2. 2. Still even. I can pull out a 2. What's 2 divided by 2? 1. Once I reach 1, I've reached the end of my upside down division. I now need to put all my prime factors into a factorization. 1, 2, 3, 4, 5, 6. So it's 2 times 2 times 2 times 2 times 2 times 2. Or 2 to the 6th power, but again, get me here. Notice I didn't need to worry about order because they're all the same number. Let's try another one. The prime factorization of 100. Okay, and I'm going to show you a mistake that people will do. Okay, people go, oh, 100, I know I can do it. 100 divided by 4 is 25. Okay, 25, and then they go from there. Is 4 a prime number? It's not a prime number. You can't pull out in the prime factorization, you can't pull out a composite number. When you're doing the prime factorization, you have to focus on pulling out those prime numbers. Always start with your smallest prime numbers and move this way, right, as you go, so that way you know you're only pulling out prime numbers. And again, the smallest is the easiest way to start, and again, it's a nice self-check to make sure that we're pulling out only prime numbers. So it's even, so I'm going to pull out a 2. What's 100 divided by 2? 50. Still even. What's 50 divided by 2? 25. Okay, now is 25 still even? So can I pull out a 2? Absolutely not. So should I try to pull out a 3? I should try. Does 3 fit in the 25 though? 3 times 8 is 24, 3 times 9 is 27. It doesn't, so I'm going to skip the 5. 25 divided by 5 is 5. Okay, am I done? No, I haven't gotten down to 1. 1 is done. Once you get down to 1, you are done. But until you get down to 1, you are not done. All right, what is 5? All right, well, I know 5 fits into 5. And how many times does it fit in? 1. And again, as I said with the last one, the common factors, this is not the prime factorization. This is the work for the prime factorization. You have to then pull out these numbers over here and put them into a factorization. You have to put them into a multiplication number sentence. 2 times 2 times 5 times 5. I'll see some people, and this is wrong. What I'm about to do in the black marker over here, actually, let me make it, in the purple marker is wrong. They'll go 2 times 2 times 5 and 5. That's not a multiplication number sentence. This is not a prime factorization. We're not listing the prime factors. We're listing the prime factorization. It has to be with multiplication signs in between all the prime numbers. If you want to write it in exponential form, it's 2 to the second power times 5 to the second power. The reason that this little number is how many times you count these. So there's 2 2s and there's 2 5s. That's why it's 5 to the second power. Let's do the prime factorization of 120. Again, if you want to try this on your own, this is not a bad place to start. Try to do this one completely on your own. Pause me, come back when you're done. All right, so again, 120 is even. We'll pull out a 2. 120 divided by 60. Giving away answers. 100 divided by 120 divided by 2 is 60. 60 divided by 2 is 30. Still even. Divided by 2 is 15. It's no longer even. All right, after 2, I should check 3. Okay, 15 divided by 3 is 5. 5 divided by 5 is 1. I've now reached 1, I am done. If you don't know your prime numbers, don't have your list of prime numbers, this becomes very difficult. You need to have that list or have an understanding of what prime numbers are. Work in order. This is not the prime factorization. This is the tool, the skill that got me to prime factorization. I now need to write it using multiplication symbols. All right. Notice I mixed it up. I don't have X's, I have dots. You will see that in 6th grade. What do those dots mean? Those are multiplication symbols. Okay, just beware that those you see those dots also represent multiplication. Here is the prime factorization of 120. And I do apologize, I didn't do this on the other ones, but if we were to multiply these all out, we would get 120. So what's really nice about these prime factorizations is if when you get your prime factorization, if you multiply all these out and you don't get the number you were looking for, you did it wrong. You messed up somewhere. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 5 is 120. 5 times 4 is 20. Carry 2. 5 times 2 is 10. Plus 2 is 120. All right. So that's why this number, this prime factorization, represents 120. No other number can have the prime factorization of 2 times 2 times 2 times 3 times 5. Listen, I understand this is a difficult one. All right, I understand this is one of the more difficult concepts we do. Biggest things you need, go back and copy that list of the first beginning prime factors, or the prime numbers, I mean. Find those, write those down, know those. Start with 2. Does 2 fit in? How many? And just keep going with the 2s until it's no longer an even number. After 2, then check 3. It might not be 3, it might be 7, it might be 5, it might be 11, it might be 19, it might be 17. Hopefully it's not 29, but just use that chronological order, 2, 3, use the number sense that you have and start with the small numbers and work your way up. You are not done with your prime factorization until you get 1, and even when you do that, you're not technically done because this is not an answer. This is an answer. Good luck. We'll spend some time in class doing this virtually. If you need help, we can set up some Zooms and talk about these, and I can look at your work. But we need to make sure that we get the prime factorizations.